In this video, we're going to talk about factoring special cases. There are two special cases, a difference of two squares and perfect square trinomials. The key thing when you're looking at these problems is you want to see if they have perfect squares as the first term and the last term. So, for example, if it says a difference of two squares, well, difference means the answer to a subtraction problem, so you want to think subtract. And then two squares, you think of two perfect squares. So, for example, if I had x squared minus 16, both of these values, both of these terms are perfect squares, and we are subtracting them, so it is a difference of two squares. Now, in order to factor them, you want to take the square root of each term. So the square root of x squared is x. That will be your first term in the binomial when you factor. And again, x times x gives us the x squared. The square root of 16 is 4. So we need a 4 as our last term, and 4 times 4 will give us 16. Now, this is the c term. Notice that there is no b term. There is no single x value. It is gone. It's canceled out. So we're going to have to be able to use these two problems and not generate a middle term. Also notice that the c value, the 16, is negative. And we've talked about in the past, if it's negative as a c term, then to multiply to get that negative, you're going to have one positive and one negative. So we need one of these binomials to be positive and one to be negative. And if we FOIL this back out, x times x is x squared. X times negative 4 is negative 4x. 4 times x is a positive 4x. And 4 times negative 4 is negative 16. The negative 4x and the positive 4x will cancel out, and you will not have a center term or a b term. So, a difference of two squares, you have two perfect squares and a subtraction sign, and then you just need to take the square root of both terms, and remember one will be positive and one will be negative. Now, a perfect square trinomial, let me write down a problem, 4x squared. It is a trinomial, so it will have three terms. And again, the first term and the last term, the a term, or the first term and the last term, will both be perfect squares. And again, you'll need to square root the first one and the last one to determine what's going to be in your binomials as the first term and the last term. So if we take the square root of 4x squared, we'll have 2x. 2x times 2x would give 4x squared. To get 25, we need to square root 25, and we'll say 5, because 5 times 5 gives us 25. Now, in this case, we have a positive c value, and so either both had to be negative or both had to be positive. And we look back here, since the 20 is positive, they both need to be positive. Another way that you can check before you really get into a problem like this is if you take the square root of the first term and multiply it by the square root of the last term. So if I said 2x times the 5, so I square root this one and square root this one, that would give me 10x. And then if I doubled 10x times 2, if I doubled 10x, I would get 20x, which is the center term. If I followed this process, I could immediately tell if this will be a perfect square trinomial. Now, at this point, when I get this written down, I can go ahead and simplify that, take it one step further and say 2x plus 5, and since I have it written down twice, I can say that it's squared. You can FOIL this back out to make sure it works. If you don't recognize that they're perfect squares and you start factoring by other methods, that is okay. You can still get the answer without having to do this. This should just help it go a little faster. You should be able to do it quicker if you notice that it is a perfect square trinomial. That's all for this video.